Hi everyone, Prof. Joyce here, and I'll be teaching you three different questions related to solving for the concentrations of mixtures or the quantities of mixtures to use to get a final concentration. This is one of the most common questions in your pharmaceutical calculations, and I hope this will help you pharmacy students with your quizzes and exams. Okay, so let's get on with it. We have three different questions here that you see, three different scenarios. The first question is, how much of a 10% zinc oxide ointment should be mixed with 2.5% 350 grams zinc oxide ointment to prepare a final concentration of 5% zinc oxide ointment? This means your active ingredient, your API, is zinc oxide. This is your API. Mean to say the activity or efficacy is based on this substance, right? And we're mixing different concentrations, different quantities, and we're looking for the 5%, the final concentration. So if you draw this for representation, you have the first preparation, which is 10% in terms of strength, and this is your unknown in terms of the amount. And you mix to this your second preparation, which is 2.5%, and the grams given, 350 grams. Okay? And the final concentration, the product, is a 5% zinc oxide ointment. Okay, so remember, the amount that you're looking for is the raw material, the 10%, not the final concentration, not this one, not the 5% final amount. You're looking for the 10% amount. So the first approach is very straightforward. You're basically converting your statement here to a math statement. So when you do this, you simply multiply the concentration to its amount. Okay, just get the first pair, add the second pair, and that's it. So how do we go about this? We get the 10%, the first concentration, multiply it to its partner, which is the amount in terms of X, that's what we're looking for, and then we add the second pair would be the 2.5% concentration and its amount, okay, equals the final product, the 5%. And at this point, what would be the one in parentheses? You simply add your X and 350 grams. These are the quantities. So you reflect that. Okay. So simplifying, if you see percentages, simply ignore them. Handle them as a normal number instead of converting them to decimal to make your life easier. So in this case, 10 times X, 10X, plus 2.5 times 350, 875, equals 5 times X, 5X. Retain your plus sign, do the second distribution. 350 times 5 gives you 1750. Okay, so these are in grams, by the way. Okay, so what we do next is we put all the X's on the other side and all the grams on the opposite side. So that means if your 10X is already on the left, let's just copy it. And then you have another X here, right? So it has to move to the other side, which means the sign will flip. So if this is 5X, which is a positive number, it will become a negative instead, since it crossed your equal sign. So this means it becomes a minus. Okay, equals your 1750 is already on the other side, so let's just copy it. Your 875 should migrate. It should move to the other side. So 875 used to be positive, now it's going to be a minus. I'm going to flip the signs. So this means you have 5x, 10 minus 5 equals 1750 minus 875. That gives you 875 grams. Divide both sides by 5. to get rid of the 5 here, your x should be 175. That is the first method. What about the second method, the allegation method? For the allegation method, you have to use a special layout. The layout is like this. You get the final concentration of your final product at the center. You put it here at the center, like so. And then all the percentages or strengths of your raw material should be on the left side. And you will be placing them in such a way that you can form a cross. So how do we go about this? You simply put the 10% here and the 2.5% here. It doesn't matter, you can put the 2.5 up and then or at the top, and then the 10 could be at the bottom. It doesn't matter as long as you form like a cross, and all of them should be on the left, and the 5 or the final concentration at the center. So when you do this, you're forming an imaginary X. So the 10 crosses 5 like so, and the 2.5 crosses the 5 like so. So it's forming an X, okay? And what you do with the numbers is you subtract them. So it means your 10%, your 10 minus 5, get the absolute number, that's your 5. Okay, it doesn't matter, you can have 5 minus 10, you still get the absolute number, a positive number, which is 5. And I want you to put P, which means parts, for ratio and proportion later on. 2.5 minus 5 is 2.5, absolute number, 2.5 parts. So what does this number tell you? It means the 10% is present in 2.5 parts, and the 2.5% is present in 5 parts in order to make your 5% at the center. Now, what numbers can we use to make your ratio and proportion? Again, remember your 10% here is your unknown, so the quantity is still an X. Your 2.5 here is given in terms of quantity, it's 350 grams. So now it's easier for you to associate. Your X is your 2.5 parts, your 350 is your 5 parts, right? So we can just simply say if, sorry, I think it's better this way. We can simply say if 5 parts is equal to 350 grams, how about for the 2.5 parts? That's your X, right? The 5P, 350, 2.5P, your X. Your X here is your 10%. The 350 here is your 2.5%. Okay, so if we rearrange, your X is basically 350 grams times 2.5 parts, 5 parts here. Okay, if you want to isolate the X, you have to do the crisscross method. If you don't know that, you still have to like practice how to rearrange your formulas. But basically, you want to isolate or put your X on one side alone. Okay, and the rest of the number should be on the opposite side. So the X goes up, the 5P goes down. Crisscross, it's already here. From here, it goes here. And your X goes up, right? Under your 350, if your X is already here, it stays there. No biggie, it's just there. Your 2.5, it's still with your X, so you need to put it up. That's why it's already here, your 2.5, okay? So you need practice if you don't know how to rearrange. Practice, math, that makes it perfect. So 875 divided by 5, you still get 175 grams. Okay, so method 1, method 2, doesn't matter. Both of them will give you the correct answer. It really actually depends on how comfortable you are. Okay, so let's do number 2. How many grams of white petrolatum should be mixed with 250 grams of 7.5% and 850 grams of 15% precipitated sulfur, this time is your API, to prepare a 10% ointment? So in this case, guys, white petrolatum is your base. It doesn't contain any API. No API, no active. So when you draw that, it looks like this. 0% no active ingredient, and that's your X. You're looking for the quantity. Plus this one is your 7.5%. Okay, that's it. And then the quantity is 250 grams. The third one is 15% higher this time. The quantity is 850 grams. And then your final product is a 10% ointment. Okay, that's not an X. That's just 10%. That's it. And so converting this again, using your method one, you have simply 0% times X plus 7.5%, 250 grams plus 15%, 850 grams, and then equals 10%. So the parentheses here should be the sum of all the amounts. So X plus 250 plus 850 grams. At this point, we can simplify this. Just add the grams. So that gives you 250 plus 850 is 1,100 grams. So mean to say the two preparations here already 1,100 grams. Okay. So we choose to ignore again the percentages. Just ignore them at this point. So you don't have to convert to decimal again and again. So again, any number multiplied to zero is zero, right? So we can just remove it from your equation. So at this point, let's do it. 7.5 times 250, that gives you 1875 plus 15 times 850. That gives you 12,750, right? Equals 10, distribute 10x, retain your plus sign, right? And then since we already added the two numbers here, you can just go ahead and use the 1,100. And since you multiply it by 10, it becomes 11,000. Again, isolate your x. So the only number that you have to get rid would be your 11,000. So we can do that, no? We can just retain the position like so. But if you're not comfortable, you want to see the x always on the left side, okay? You can just simply flip this 10x is here. Just copy all the numbers you see here. Just flipping, okay? And then this one becomes a minus sign because you're transferring your 11,000 to the other side. Remember? So that means 11,000 becomes a minus sign. So 10x equals, let's do this in our calculator, plus 12,750 minus 11,000. That gives you 3,625. Divide both sides by 10. Okay, your x is 362.5 grams. Okay, that's for your method one. So how do we do it for method two? Okay. Let's add, I think we could add, okay, and then let's copy this one and then try to paste it here. Okay, let's do the method two, alligation. So when you're doing alligation, you can only handle two pairs of raw materials and one final concentration, like what we did for the first question. So in this case, you need to find, okay, the first, diba, we're looking for this kind of layout. The 10% would be your final concentration, and you need the first concentration here and the second concentration here. That's what we're trying to do, right? Okay. What we can do actually is automatically set the first raw material here is your white petrolatum. Again, this is a base, meaning no API, meaning to say it is equivalent to 0%. So we can just, just straight ahead, okay, one raw material is 0%. with your white petrolatum. And then let's look for a way that we can look for the concentration of your second raw material. And the second raw material here would be the ones with your active ingredient. So this is basically a base plus an ointment with API. That's the scenario here. So if you want to do that, okay, this is how you should do it. Okay, you have a 250 grams. Okay, do you want to draw? Let's draw. Let's draw. So you could understand. So again, you have a 0% here. And then what we're doing instead is this one is the first raw material, and the second raw material is basically your 7.5 and your 15%, which are presumably mixed already, right? That's the scenario here. So how do we find the second raw material? This is how we should do it. 250 grams times, still the same, 7.5%. To look, this is to find for the final concentration of the two mixtures, submixtures. 850 grams times 15%. So if we do this, guys, what we're getting is a number that represents the active ingredient alone. So that means 7.5 times 250. This means for the first mixture, the one that you see here, this contains 18.75 grams of your precipitated sulfur, of your pure API. For the second one, that's 15% times 850. This is 127.5 grams of your API. So if you add them together, the total API would be 18.75 plus 127.5 gives you 146.25 grams. This is for your API or your solute. Okay. How about for your solution? The total amount or quantity is 850 plus 250, which gives you 1,100 grams. So remember, when you express this in terms of percent concentration, weight by weight, okay, we simply get the ratio of your solute over solution times 100. Remember? In terms of grams. That's how we solve for it. So if we do that right now, your grams of solute already solved by you is 146.25. And then the grams of your solution would be the 1,100. You're just getting the total times 100. If you solve for this, this gives you, okay, the number that comes out from my calculator is 13.295. So I would like to retain up to 3 decimal places. Just to be safe, okay? So this will be now your concentration. So now we can get the second component is 13.295. So we can simply use it here. We can erase this. Okay, I already know what to use, and that is 13.295%. So now we can do the crisscross, the x. This gives you 10 parts. 10 minus 0, 0 minus 10, get the absolute number. And then the other one is this one. Okay, so 13.295 minus 10 is 3.295 parts. Okay, so that means again, your 0% is represented by this, and your 13.295 is represented by this much parts. Okay, at this point, what is known to you is your 13.295 in terms of quantity. Remember, your 0 is still x. This one is already given. You already know this. This is 1,100 grams, right? So now you can simply, oh, if 10 parts is 1,100 grams, then my 3.295 parts is my x. So again, isolating your x, this goes up, this goes down. X equals your 10, p goes down. Since your x is already here, you simply have to like retain your 1,100 grams. And then since your x is on this side, you have to switch this up, move it up. 3.295 parts. So now you isolate your x on the left. Okay, so you can now do cancellation. 1,100 times 3.295 divided by 10 gives you 362.45 grams. So that's the final answer for step or method 2. Let's check. Oh, 362.5, 362.45. It's an approximate. No, they're like more or less the same if you round it up. Okay, so that's the second scenario, and we're down to our last number, and this is very easy. Let's do method 1. Okay, you got this. So follow me. What is the final concentration if we mix 250 grams of 15%, 300 grams of 2.5%, and 250 grams of ointment base? Again, remember, if it's an ointment base, it means it is 0%. So again, when you see, take note, students, if you see the word of, it immediately means to multiply. It's equivalent to multiply. You have to use your times. Okay? So here, we're mixing. So we're adding them together, plus sign. So this means, what is the final concentration? Okay, if we mix 250 grams times of 15%, we mix, so we put plus sign. Next pair, we have 300 grams of 2.5%, and the last one is 250 grams, and since it's 0%, let's put it 0%. Okay, and then you have your x. You don't know the concentration, but you already know the amounts. You simply add 250, 300, and 250. So the concentration is unknown, but you know the quantity of the final preparation. It's the sum of all the quantities of its raw materials. Right? So if we simplify this, we get 250 plus 300 plus 250. The final is 800 grams. Okay, that's the final if you add all of them. So let's do this. Okay, remember this one is already removed because any number multiplied by 0 is 0. Okay, so I think we can simply approach this ignoring again your percent. So 250 times 15, 750 plus 300 times 2.5, you get 750. So we already removed this guy. X times 800. Okay. So what do we do now? So this becomes 800x simply, right? So that means 750 plus 750, that gives you 4,500. This becomes 800x, right? We simply multiply it that way. Okay, divide both sides by 800. Your x is now 5.625. This is already in percent. Remember, we didn't, we ignored this. We didn't convert it. convert it into decimal. It's still in percent. So your final answer should be already in percent. Mind you, if you converted this while doing your calculation to 0.15, 0.15, then your final answer should be smaller and you still have to multiply it by 100 to get the percent. Okay, so this is now the final answer. Okay, so that's it. That is your three different questions related to mixing different preparations at different amounts at different concentrations. If you have any question, let me know. And also, if you have sample questions out there, put them on the comment section and then let's try to solve it all together. Have a great day.